everybody, welcome back to another Napa STEM Academy science lesson. This week we are going to be using science to make our own ice cream. In this lesson, we are going to be using kitchen chemistry to explore the states of matter and make a delicious treat. Before we get started, you guys know the drill. We got to learn a little bit about the vocabulary behind this science. First off, let's talk about the states of matter. In physics, which is a type of science where we talk about the physical characteristic of things in our world, there are three states of matter that are observable in everyday life: solid, liquid, and gas. So how do we tell the difference between these different states of matter? When we look at a liquid, we can see that the molecules that make up a liquid can freely move amongst themselves. It is a fluid that conforms to the shape of its container, but retains a constant volume independent of pressure. An example of a liquid that we all know would be water. Then we have a solid. In a solid, the molecules are closely bound together and have a definite shape that only changes when force is applied. For example, when water is frozen, it turns into ice. When you pick up ice and touch it, it doesn't really move around that much or change in your hand. You would have to put a lot of pressure in order to crush the ice. Then we have a gas. In a gas, the molecules move freely and are independent of each other. It is different from a liquid where the molecules are loosely attached. An example of this would be steam. When we boil water, you can see steam begins to rise off the pot. That would be the gas form of water. When you think of ice cream, you think cold. So of course, we'll need to talk a little bit about temperature before we get started. Scientifically, temperature is a physical quantity that describes how quickly molecules are moving inside a material. In simple terms, temperature is how hot or cold a thing is. Which brings us to Fahrenheit. Fahrenheit is a unit of measurement used to measure temperature. Fahrenheit is most commonly used in the US. Celsius is also a unit of measurement used to measure temperature similar to Fahrenheit. Celsius, also known as centigrade, is used in most other countries. When you think about foods and goods that need to stay cold, you may notice that in your own home, there are some foods and things that stay in the refrigerator, and other foods and things that need to stay in the freezer. Why can't all of these things just stay in one place if they just need to be cold? This can be explained in part by the freezing point. Freezing is the process when a liquid turns into a solid. Freezing occurs at below 0 degrees Celsius with water, while other liquids become a solid at higher or lower temperatures. So for ice and other frozen goods that you keep stored in your freezer, it makes sense that you would keep them separate from things like produce or milk, because the freezer freezes things at a lower temperature. We're almost ready to go, but let's learn a little bit about the context behind what we're doing. What is ice cream? Ice cream is made up of droplets of fat from milk jumbled up with millions of tiny crystals of ice and pockets of air. Why is temperature important? Temperature is an important parameter in chemistry. As the temperature of the matter decreases, there is a point called the freezing point, which we just learned about, where the matter transitions from liquid to solid. When temperature decreases, the motion in the molecules also slows down. When was ice cream discovered? A kind of ice cream was invented in China in 200 BC when a milk and rice mixture was frozen by packing it in snow. What does science say about ice cream? Ice cream is made up of 5 basic components: air, sweeteners, fat, ice crystals, and other solids. The scientific secret to making homemade ice cream is rock salt. Why add salt to the bag containing ice before shaking to make ice cream? As the ice melts into water, the salt allows the water to go to a temperature lower than the ice, which allows the ice cream to freeze. Without salt, it's very difficult to make ice cream. Now that we've armed ourselves with plenty of science knowledge, let's get started with our activity. For this one, you're going to need the following materials: 1 cup of half and half. Now, for this experiment, we used a dairy-free substitute to make sure it was the same, and it tasted just as great. So if you need a dairy substitute of half and half, you can use that, and it'll be just as good. You'll also need 2 tablespoons of granulated sugar, a half a teaspoon of pure vanilla extract, whatever toppings you like on your ice cream, at least 3 cups of ice, a third cup of kosher salt, Ziploc bags, 1 gallon sized and 1 sandwich or quart sized, gloves of some kind, a towel to catch any water, a bowl and a spoon or a container with cover to freeze and save for later. To start off, we're going to use the smaller Ziploc bag to combine the half and half, the sugar, and the vanilla. Once it's all together in the bag, push out any excess air and then seal and shake to mix. Once that's done, you'll grab your big Ziploc bag and combine the ice and salt inside. In step 4, you'll place your small bag of sealed cream into the larger bag and shake vigorously for 7 to 11 minutes until the ice cream has hardened. This is a long time to be shaking that bag, so I suggest putting on some good tunes and doing it with a family member in order to make sure the time passes quicker. You'll want to maybe put on a timer on your oven or on your phone like I did. Here's a helpful hint. Keep the milk in contact with the ice as much as possible. As we learned before we started, ice and salt equals very cold, so make sure you use a towel or some special gloves to protect your hands. Once that timer goes off and your arms are super tired, remove the small bag from the large ice bag and enjoy with your favorite toppings. If you want to make this experiment even more fun, try this. With the help or permission of a parent, make new flavors of ice cream by adding new ingredients to your base, such as fruit, nuts, and chocolate chips. Experiment with the original recipe before adding any new ingredients to the mixture. Let's do some critical thinking about how salt affects our real-world life. Salt is used in cold climates to melt ice on roads and walkways. Can you think of some other ways we use salt outside of the kitchen? If you want to extend the activity, here are some added questions and experiments you can do. Is there a difference in freezing cream, half and half, and milk? Why? If you used chocolate milk in place of half and half, would it make chocolate ice cream? Do different ingredients change how the cream freezes? If you have a kinder through second grader, consider using smaller portions or cutting the recipe in half. This can help speed up the process, especially the freezing process. If you have a third through fifth grader, consider having your student invent their own flavor of ice cream by adding ingredients they feel would be original and different. You could also put them in charge of dessert for one of the meals during the week. We hope you had fun exploring the science of ice cream today. Make sure to send us some photos so we can see all your awesome zany creations. We'll see you next week with a new science video.